Okay, and a good morning. And that should have been the Cranberries, and that should have been Dreams that we were listening to just as it finished out. And one of the things that occurred to me on last Thursday, because we had the midterm, that there was no opportunity for you to ask questions on the formulas, and my intent this morning was to have the formula test. But it occurred to me that I hadn't given you enough time to ask questions or to review just before the test. So I thought I should back off from that for one day. So today, we're going to spend time on formulas. And I have some problems that we worked on in the last hour. I just want to go through each of those and talk about them. And I'd like you to see if you can, as we look at them, draw the diagram, replace the diagram that you see. And before we look at the solutions, the idea being that you would try to do the problem. And then we'll look at the solutions on the board. So I'm going to work on the computer to do this. Now, this first problem is the toughest one of the group. So we're going to go to the document cam, Debbie. Here's the diagram. So this is one of the problems, and this is part that we didn't get done the last hour, the distance around that. Now I'm going to zoom in on different parts of this so you can see it. So let's see what we can do. In this, boy, that doesn't look very good, what happens on the computer. Wow. That doesn't look good at all. See, that's supposed to be a half circle on the side of a 3, 4, 5 triangle. So draw yourself a 3, 4, 5 right triangle. You have a rectangle on the diagonal, and you have a half circle down below there. I'm going to zoom out so you can see what it's supposed to look like. The numbers, it's a 3, 4, 5 on your right triangle. And the dimensions, 3 feet on there, sliding over and up. That's 4 feet for the diameter of the big circle, and 5 feet for the side of the rectangle, which also has 3 feet up there. Yeah, I'm going to. Look at the screen now. That's what we did in the board, and that makes, thank you, Debbie, very nicely done. Appreciate that. Draw that. Spend some time drawing it. It doesn't have to be super pretty, but it should be at least like what you see in the board, which isn't all that great, but that's the diagram. Draw it first, and then your problem is to find the perimeter or circumference of that diagram. You do not count the dashed lines creating the right triangle. Okay, so what you're trying to do is give me the distance around. So you have 2 half circles and 3 sides of a rectangle. And once we have the perimeter around that, I want you to get the area inside. And we'll compare your answers for the area, but right now we'll do the distance around. So I need to have you work on that. So you want the distance around. And I'll be working in the document cam with you in this and what you're seeing on the board. So distance around. If you'll focus on the big circle, that will help us. So I want to start with the big circle. That's what I'll ask for there. Lordy, it held. Okay, now just for an example, this is the circumference of the big circle over 2, because I have half a circle. So you have 2 pi r, that's the circumference of the big circle. The radius is 2 feet, and notice how the 2's canceled. So if you look at what I've done there, I took this 2 and canceled them, so you just get pi times r. If you look at the other diagram that Debbie has now, notice half the distance across that big circle is 2 feet. So you're getting 2 feet there. Okay. Now that's the distance for that first half circle. Now you're going to have to do the same thing as we come back again. This bottom circle has a diameter of 3 feet. So let's see what you can get there for that part. So 3 feet in that, and again, I'll just write out what we need here. While you're doing that, and it's nice that we're doing half circles because it gives us a way of canceling the 2 in the formula. Now notice the radius there is 1.5 feet. Now just a reminder, you will be able to have a calculator. Okay, Debbie, this is what you'd have so far. 3.14 times 1.5 feet. So that's going to be 4.71. Okay, so 4.71 feet. Writing that in. Now let's go back to the diagram that we're looking on the screen. What do I still have to add into that? 3 sides of the rectangle. I'm not doing the whole rectangle, so you want the perimeter for that. Will you write that in for yourself? We'll just leave that on the screen. Now we aren't finding area. All we're doing is finding the distance around. So in this case, I don't think in terms of a formula in this part. I just add some pieces together. So if we look at the screen, this is what you do there. You have your 3 feet plus your 5 feet plus your 3 feet. And that would be what? 11 feet. You have 3 and 3 and 5. Let's go back to the diagram. I don't have but 3 sides to that rectangle I'm walking on. The 3, 4, and 5 of the triangle have nothing to do in this problem because I don't walk on those sides. Think of walking around that shape, so the solid lines are where you're walking. So we said this was 11 feet as we go back to the document cam. So I add that together. 11 and 10 is 21. So it looks like I have 21.99 feet. So you can see all those on the screen, adding them up. So 21.99 feet for the distance around this shape. Leave that on the screen just for a moment longer. Now, is there any question in that? You can see the parts up there. And this is the kind of problem you'll have in your test. You'll have one like this where you find perimeter, and then we need to find the areas. Okay, let's come off that. Back to the diagram now. One more time, Debbie. Now what's the area? We have 4 pieces there. So you have the rectangle. We can find that pretty easy. We have the triangle. That shouldn't be too bad. And then you have 2 half circles. So will you just get me the area for the rectangle, the area for the triangle? Do that part first for me. Area of the rectangle as you see the screen on the monitor. So you want the area of the rectangle and the area of the triangle, here you have to use formulas. So you'll have two formulas you write out. I'll let you do that first. Get that much going. Just waiting for you to get some things written down. Still waiting for you. Two areas I want. Area of the rectangle and the area of the triangle. There's a triangle in the middle, so let's get that one done too. There are two areas I'm wanting there. See if you can get those. Area of the rectangle, the area of the triangle, then we'll go for the circles. Area of the rectangle, area of the triangle. Okay, let's see what I have here on the screen for you. The area of your rectangle is length times width, and that was 3 feet by 5 feet, and that gives you 15 square feet. Your triangle was a 3, 4, 5, the diagonal we don't use. So what you have there is your 3 times your 4, that's 12, over 2 is 6 square feet. Now the question is, what am I going to do for those circles? Okay. Now, looking at the circle, keep in mind the radius of the big circle is 2. You want half the area of the whole circle, so we have to be careful of that. Half the area of the whole circle. So if I talk about the area of a circle, I'm going to divide that by 2. So what you should have as a formula is what I'm writing on the overhead now. That's pi r squared divided by 2. And what is r? It's the radius, and in this problem, as we go to the other shot, it is 2 feet for the big circle. The diameter is 4, so we're doing 2 feet. So we'll just leave that up on the screen for a moment longer. Let's see what we can get by substituting. Now when I talk about the formula and the substitution, what I have in mind is what you now see in the screen. Here is your pi at 3.14. The 2 feet times 2 feet. That's the radius squared, and it's over 2. Now what can I do with one of those 2's? Cancel it, agreed? So I can cancel right in here. So as we come off there for a moment, now as we look at what I have, that's just 2 times 3.14, which is what? 6.28. So coming off there for a moment, 6.28 feet squared. Okay, coming back. Now I need what? The area of the other circle. So coming off there, let's have you do that one. The area of the circle, again divided by 2. Same formula. But this time, what is your radius going to be? 1.5, right? So it's not so easily done. So this last one that I have on the screen, is a little bit harder to calculate. That's 1.5 times 1.5 times 3.14 divided by 2. And as I say, you probably will want to use a calculator to help that one. So we'll let you get that for me here in a moment. So the calculator to do that, and we'll write a number down here in a moment. If you do it longhand, it's just a little bit more time consuming, but I think you'll want to bring a small, non-scientific calculator for the test, because the scientific one is not one we're going to use. This is just your basic 4-function calculator, and what I have in mind is something like this. Let's go to the camera. That's the kind of calculator that we're going to use as we go through things. So it's not a scientific one. It just has a square root key, has a percent key, has division, multiplication, subtraction, addition, a little bit of a memory that we'll use, but these sell for what, about $1 now? Maybe $1.99, depending on where you... 99 cents to $1.50, pretty inexpensive, cheaper than coffee these days. Would you have believed that? First calculators back in the early 70s, okay, that's 30 years ago nearly, 35 years ago. A calculator would do just that much was $100. $100, and you can buy it for $1. And they were bigger. They used batteries. They weren't solar. But you paid $100, and all it did is what this calculator does again. For $100 in let's say 1971, 72. So about 34 years back, $100. It was called the TI Data Math. If you can still find one at a garage sale for 50 cents, not bad buy. Now, that calculator, $1 now. By the way, a new truck, same period, 1971, $3,000. Now, $25,000 to $30,000. So about the price of a truck is 10 times as much. The price of a calculator, divide by 100. Some things do get cheaper. Okay, what is your answer for that calculation? Somebody have it now. Anybody? Okay, the number I'm going to write down is what Teresa just stated, and she gets 3.53 square feet. That is correct. So now, what do we have to do? We have to add all these together, and am I going to get that top one? Let's take these up here. We have 15, and 6 is 21. Then 6.28, so that's 27.28. 27.28, so let's come off there for a moment. And a 3.53, and it looks like we're getting about a 30.81 feet squared. So this is the number I think I'm getting here. 30.81 feet squared for that problem. Any questions on that?
So you added
I added all the parts. So I found the area of each part. So let's come back to the diagram. I found the area of the rectangle, the triangle, and the 2 half circles. Okay? And that's the number we have down there. Okay, coming off that, let me give you an idea of what I'm doing up here and what I need to do. Okay, remember this is the diagram on the screen that we're looking at, and this came from a review set of problems. So let me back this up for a moment, Debbie, and we come off there just for a moment. I'm going to back this up to the website that I'm on, so you just have an idea of what's happening here. This is the review sheet section. I'm going to back up one more time, okay, because this is the home page. This is the URL. Okay, and what I'm doing is looking at the left side of that, and there will be review sheets. So I look at this, click there, and when I do that, I get the review sheet section. And if I look over at the left side and I scroll down, you'll find Formula 1 review, Formula 2 review, Formula 3 review, and answers for each one. We just did the third one. So I'm going to come back and look at the first one. Now, I tried printing this up, and I just want to, I will show you in a moment the disaster that occurred. Okay, because the printer went to printer heaven, or printer hell, depending on how you want to think of it. Now, this is, as I bring this up to the top, this is the review sheet for formula problems. Let's come off there for a moment, Debbie. This is what happened as I tried to print this. The printer has a shredded ribbon at this point that reminds you of an 18-wheeler with the radial tires that are starting to disintegrate, and they start flipping around. Well, that's what it looks, that's the image inside this printer. So coming back to this first problem, the intent was to find the area and circumference. So let's look at that for a moment before it completely goes down, like the sun at sunset. The area and the circumference, okay? Of what? Of a circle, quickly, with diameter of 4 inches. You got it? Coming at you quickly. So it is a circle with a diameter of 4 inches. And I want you to get the area and the circumference before we go to the board in that. Okay, so again, you have a circle with a diameter of 4 inches. That's what we have on the screen. Diameter of 4 inches. It's just like the circle we had in the diagram on the sideboard, but this is a whole circle, and I want the area and the circumference. Area and circumference. It's not a half circle. It's a full circle. Try doing it without referencing anything on the boards. Try doing it on your own. Okay, so the area and circumference of this circle is what I want. Now there's a complete other set of review problems that you could reference. Okay, but for the moment, we'll just take this one. And I'll leave that on the screen for a few moments. At some point, we'll go back and look at the results. Okay, come off there for a moment, Debbie. Now, just a reminder, this is where I'm getting this information if you want to spend time with it. This is your URL that gives you that page. So you could go back and practice some of these your own if you go into any of the computer labs on campus. And you type that in, you'll get to a page that has Math 10 on it. Click on Math 10, and you're right where we are on the computer now. Okay, so that is, again, the URL. So I'll leave time for people to write that out. It's virtual, Yosemite, CC-CAUS. There's periods between everything until the US. Then it's a slash, forward slash, like a fraction line, JCURL. Okay, Debbie, come off there. Now, what we're going to do, Debbie, is come to the solution on the front board. There is what I ask you to do. Let me get the glare off the lamp for a moment. Here is your circle. It's not the greatest looking circle in the world, but it's 4-inch diameter. Now you have two formulas you can use for circumference. You can do 2 pi r, that's the traditional form, or pi times d, because 2 times r is the diameter. Well, the diameter was given to me at 4 inches, so I have 3.14 times 4 inches, and that should give you the 12.56. Now note, I put an equal sign with a dot above it because pi is an approximation. When you write 3.14, that's just the closest you can do. So it's only approximately equal. So about 12.5 inches. The 2 times r is d. The distance from the center to the outside is 2 inches. 2 times r is 4.
So you never have to use the 2 then?
Here's your 2 inches, correct? So if you do 2 pi r, what do you get? 2 times 2 inches, which is 4 inches, times pi. The diameter is just 2r. These formulas are interchangeable. So I can use the diameter at 4 inches, or I could take 2 times 3.14 times 2 inches, which is 4 inches times pi. Either way will work.
Okay.
Now, what about the area? Pi times r squared. So that's going to be 2 inches times 2 inches, which is 4 square inches. Again times your 3.14, and again comes out what? 12.56, but this time it's what? Square inches, not inches. So even though the numerical part comes out the same, the circumference was inches, the area square inches. That'd be a very typical problem I'd ask on the test. Adrian.
I thought I added, what I did was the 3.14, which is pi times radius squared, right?
Yeah.
Okay, so I would think squared meaning 2, meaning 4 times 4. That's what I did.
Okay, let's go back to the diagram.
I did.
What is the radius? Is the radius 4? The diameter is 4. The radius is 2. So you can't take 4 times 4 because the diameter was 4. This distance across here was 4 inches. That's not the radius. That's the diameter. The radius is 2 inches. So if I come back to my formula and substitute here, 2 times 2 is 4 square inches. So you have to make very carefully a distinction between radius and diameter. So again, this is the radius here. And this is the diameter. So if I give you the diameter, you have to do what? Cut it in half to get the radius. So pi r squared then is 3.14 times 2 inches times 2 inches, which is the 4 square inches I have right here. When you multiply that 4 times 3.14, 12.56. Okay? Okay, let's go back to the document cam in a moment, since I need to get, okay, we just did the area and circumference of a circle. Let's bring up the second one. So in this case, I have the perimeter and area of a triangle. The base is 6 feet. The height is 8 feet. The diagonal is 10 feet. So let's just get the diagram only for the moment on the screen. I'll walk off camera so you can see it in the screen. I want you to try the problem without looking at the solution. Look at the screen now for the diagram. Look at your monitor. So it's a 6 foot by 8 foot by 10 foot. So you should write or draw that shape. That would be expected. So that's the first step in your solution on the test. You'll need a straight edge for your test. So you're going to draw me a right triangle that's 6 feet by 8 feet by 10 feet. We'll just leave that on the screen because I would prefer that you not at this point see the solution. So what I want you to do is just draw the shape, then get the area and the perimeter. You'll need 2 formulas. Let's see what you can do without referencing the board. Perimeter and the area. So you want perimeter and area. So again, the way we're doing this is you're just working on the problem, finding the perimeter and the area, but not referencing my solution at this point. So you should have the perimeter and the area as a formula that you should be doing. Okay, if you know the formula for perimeter, you already have that part. So let's slide over just enough to pick up the perimeter up here. So we'll slide over just, there we go. That's what you should have written. Base plus height plus diagonal, 6 feet, 8 feet, 10 feet added together. You should have 24 feet. Okay, let's just swing down to the bottom part, just that much. Again, I'll stay off camera. Let's bring it down as we go to the area. I need this part right here. Okay, and that's 1/2 the base times the height. Notice it can be BH over 2 right here. 6 feet times 8 feet. Notice the 10 isn't involved here. The base was 6. So if we use the other camera for the triangle again, we'll leave that one on the screen. Okay, and we'll try to do the other one just for the triangle, bouncing back and forth. For that triangle, the base is 6 feet. So this is the base here. Then you have the height up here. So you're taking those two and substituting them into the formula now. So that's where the 6 comes from here, and the 8 here, divided by 2. So you cancel. 2 into 8 is 4. 4 times 6, 24 square feet. Now notice we had the same answer, 24, but 1's feet and 1's square feet. So the area is square feet. Okay, now what camera are we on at this point, Debbie? Number 1. Okay, why don't you bring number 2 back to me just for a moment. Now remember, what we're doing here is finding the area and perimeter for a right triangle. And we want to be able to do that for a circle, for a rectangle, for a right triangle. And what we're going to do is come back to the document cam at this point. And what I'm going to do is scroll down to the 5th problem. So just stay focused there. I'll scroll down. And here is the problem. The volume of a sphere, and the sphere is 3 meters in radius this time. So what I'm going to have Debbie do is give you a shot of a sphere. You should try drawing your sphere first. Try drawing a sphere. It's like a basketball, like a weather balloon. 3-dimensional representation. So let's see what you can do drawing a sphere. Let's see what you draw. It's got a radius of 3 meters. Now, a meter is about a yard, so it's like 9 feet nearly just for the radius. Okay, Debbie, do you want to run that as a screenshot? That's what it should look like. Okay, that's what you should be drawing. Three-dimensional representation. Well, you have a big circle and 2 ovals, and then you do some dashed lines. So one of the things you're going to practice on is drawing shapes for tomorrow, because I grade you on the shape that's drawn, the formula you write, the substitution you show, and the answer you get. Now remember, as we come back to the document cam, you're to find the volume of that sphere with a radius of 3 meters. So let's go back to the diagram. Write your formula without looking at references. Just give me the formula for volume of a sphere. So I want the volume of a sphere for a formula. This is one you should have memorized. We'll give you a chance to do that, and let's see if you can get an answer. Use the calculator. We'll see what you can do. By the way, this is not a bad problem without a calculator. Okay, but nonetheless, see what you can do. Your formula should have been 4/3 pi r cubed. Okay, that's what you should have written out. 4/3 times pi times r cubed. Then you should have an answer for all that. And hopefully you'll get an answer that we can compare. Hint, I would multiply 4 times pi, then 3 times 3 times 3, and at the end divide by 3 in the calculator. But we'll give you a little bit more time to get the volume of that sphere. Okay, back to me for just a moment, Debbie. What kind of units should you have in your answer at the end on this one? Cubic meters, because it's a three-dimensional object and we're finding volume. So you're going to want to have three-dimensional units, meaning cubic, in this case, meters. Okay, Debbie, let's bring that back now. Give me the solution with it, please. That's what I thought you might be doing. There's your solution. Now notice I substituted and then did a simplification because I had a 3 down here and a 3 up here. They canceled, so I have 9 times 4 is 36 times 3.14, and that gives you 113.04 cubic meters. Okay. Any question in that one? Okay, let me go to a different problem. Okay, let me try to get this centered a little bit better. Okay, this is the area and perimeter of a rectangle. The length is 25 yards, the width is 12 yards. So it's 25 yards long, 12 yards wide. Area and perimeter. First, try drawing the shape before you do anything else. You draw the shape for me. A rectangle, 25 by 12. Those are yards in each case. So 25 yards and 12 yards. The width is 12. Length is 25. Units, yards. I want the area and the perimeter. Write the formulas and draw the shape first. So formula and shape. 2 problems there. Okay, Debbie, do you want to bring in the shape? There's what you're supposed to get. It's 12 by 25. That's your rectangle. You want the area and the perimeter, so you need 2 formulas. So I'll let you write those formulas and show your substitution and get your answer. Again, the kind of problem that you would see in a test, which will be again tomorrow. And remember to bring your orange book with you, because you will spend the entire hour with that, and we'll rerun this tape for tomorrow as our presentation. That'll be shown at 3 o'clock in the afternoon. Pardon? It is being shown right now. I didn't realize that. Really? I'll be darned. So we're at 7 o'clock and 9 o'clock and 3 o'clock, 4 o'clock, 5 o'clock. I'm cluttering the airwaves. Okay, back to me for a moment. What's your formula for area of a rectangle? LW, right? Length times width. And for your perimeter? 2L plus 2W. So what Debbie's going to show you on the monitor now is what your solution should look like. Let's take the perimeter first. Now I have 3 different versions of what you can use for that formula. We have 2L plus 2W. We have L plus W plus L plus W. And 2 times W plus L. These are all variations of what you can use here. We're using the first one, but you will see either one of these others. Anyone's okay in the test. This is the one that I have, probably the simplest version. So you have 2 times 25, 2 times 12. There's your 50 yards, your 24 yards, a total of 74 yards. Notice we have yards in that as our unit. Okay, coming off that for a moment. Now, when you do the area, what should you have in your answer? Square yards. So we'll just focus on the area part of that. As we look at that, that's your formula for area. L times W, the 25 yards times the 12 yards for 300 square yards in that particular case. Okay, any questions on that one? If not, here's number 3 for you, for your viewing pleasure. This time a cylinder with a volume of, well, you want the volume, I should say, and the radius is 6 centimeters across, height 10 centimeters. So the question, come back to me for a moment. How big is a centimeter? Look at your pinky. Okay? Look at the distance across your pinky, about where the cuticle is. That's 1 centimeter. Just 1 centimeter. Now, if you look at your pinky and look where the cuticle is, that much from your cuticle up to the tip of your finger is about 1 cubic centimeter, what's called a cc. Okay, so you should draw me a cylinder, and Debbie will show you what that diagram should look like. That's what your cylinder should look like. By the way, think of a can 10 pinkies high and 12 pinkies across. How big do you think that is? How much would it contain? Any idea what we're thinking of in terms of the quantity there, if it's 10 centimeters high and 12 across? Just let you think about that for a moment. What is your formula for a cylinder to get the volume? Okay, pi r squared h. Remember the Cavalieri principle? If you cut the cylinder across with a cross section, you get a circle. So you take the area of your circle times the height. It's the same way we could do a prism that was triangular, remember like the corner of an aquarium that gives you light refracted, you would take the area of a triangle times the height. If you have a box, you can think of getting the area of the end of the box times its height. It works the same way for any object like that. So volume is pi r squared times h. So you write the formula down, show your substitution, back to the diagram just for a moment. We'll just take the diagram. I know you were anticipating a little bit more than that. There's your diagram. So you have a 6 for the radius, a 10 for the height. That's what you're going to substitute. And again, try to do it just from the monitor so you aren't seeing the solution. See if you can get the volume, because that's what you'll be expected to do tomorrow. Okay, so keep looking at that. Okay, come back to me for a moment. And Debbie, what we're going to do in just a moment is show the formula and the substitution for the volume, so I'll let you bring that in. And this is what you should have written. There's your formula, pi r squared h. Now notice the substitution for pi at 3.14. Then you have 6 centimeters quantity squared times 10 centimeters. Okay, so this part's unfortunately just a little bit crowded up here, but that's a 6 centimeters here and a 10 here. I don't know if we can bring that in a little bit tighter for people to see who are watching this on a television monitor, but I'll let Debbie try to bring that in tighter. Very nicely done. Thank you. So we have pi r squared h, and that's multiplied then when you substitute. Now what I did here in the solution, just to there, you'll note I took 10 times the 3.14. That moves the decimal one place to the right, so you get 31.4. 6 squared is 36. So that's what I multiplied. And as we bring that down, just to the bottom, there was the solution. And notice it's very similar to what we had with the sphere, but this time we have 1,130.4 cc's. Now, leaving that there for a moment while I talk about it. A cc is the same as a milliliter. So that means that this container has more than 1 liter. A liter is 1,000 milliliters, or 1,000 cc's. So this would be 1.1 liter. Now think of that soft drink that you buy in a plastic bottle that has a liter. Well, that's what this contains. Okay? So milliliters and cc's. For those of you who, in terms of measuring engine size, we talk about a liter. So a 4-liter engine means 4,000 cc's. So that's the idea. Okay, now we've done rectangles, we've done triangles, we've done circles. Let's see, we've done volumes of spheres and cylinders. That covers an awful lot of what would be on the test. So you're going to find the same kinds of questions being covered on the test. Let me take a moment to come back, and I'll do this in just a moment, Debbie. Let's come back and look at the document cam for just a moment. Now we did the formulas for the first. Let me come up with the second one so you can see what would be there. If you wanted another diagram to work on, this is an interesting one. Okay, let me see if I can bring that up just a little bit. Let me zoom out and bring it up so you can see what it is. There's the diagram. So that is a little square down here in the bottom, right in here. You have a half circle over here. You have a big rectangle, and then you have to subtract out what? This cut for the right triangle. Now that one has a solution with it online, so that's another diagram you could practice on. And so what do you need to do for tomorrow? Make sure that you have the unit done in your book, because you're going to turn in the orange book to me while you're taking the test. You must memorize the formulas. You need your calculator with you, and you need to do what will be much of what we did today, about that many problems for a full hour.